You're going to want to make sure you have your Google Doc engineering notes out, and I'm going to give you a quick lesson on stormwater storage and treatment. So let's take a look. First off, there are code requirements. A stormwater management system is often required to restrict stormwater runoff rate to pre-development levels. And so you're going to learn more about that coming up, and to treat stormwater so that runoff is relatively clean and free of toxins. So there's quantity code requirements and quality of water runoff code requirements. Stormwater management devices, there are two options here. There are retention ponds that will retain water. These are wet ponds. They collect the stormwater in a permanent on-site pond. So in Colorado, we don't have too many of those because it is difficult to maintain in arid and semi-arid climates, which is Colorado. So these generally will collect stormwater in a permanent on-site pond, and it treats it by allowing the pollutants to settle to the bottom. Water can then be reused for irrigation. So we might have things like reservoirs that we use as sort of retention ponds, but they're generally very large, these reservoirs that we have. But they allow these pollutants to settle to the bottom, and then biological action can occur there. So here's some sort of example of retention pond. And again, you most likely see these in wetter climates. There's also detention ponds or dry ponds, and that's most often what we see around here. So these are extended detention basins that collect stormwater and slowly release it into the municipal stormwater system. It does treat the stormwater because it detains it and allows the water to settle into the ground, where roots and the soil can kind of treat that stormwater with that microbial type action. Limitations, again, the drainage area should be at least 10 acres, and you can have small release pipes that clog. These are some of your limitations. We took a walk outside. We've done that before, maybe with your group, and taken a look at some of our detention areas, but you're always going to find overflow areas that once it's detained enough water, it's got to let a little bit out. And if those are clogged, then the whole thing can overflow if there's enough water, and that can be, again, a limitation. So here is a little video of a detention pond. It would fill up in this area. You can see this right here. So the water is draining into this little culvert right here, and then you might have some release areas, and that was Mr. Katie behind me. All right, so here's a couple other pictures of detention and retention ponds. You can pause this and read this through, but it's mostly what I've just been talking about. A retention pond area where the water might drain in here, and there'd be some sort of an overflow. This is a great example of a detention pond. It's just kind of a hole in the ground here. Water has filled it up, but you can see this is the overflow area. This is the area where they have determined that excess water will flow, and you can see they put gravel here, so when it flows off, it doesn't erode the ground. So any excess water, rainwater that comes into here, will slowly start to trickle over the edge. Now there's also the option of underground storage tanks. It's kind of a variation of a detention pond. It detains the water for short periods before an overflow system allows it into the stormwater system. These can be very expensive, but it's fine for smaller drainage areas. There's also stormwater wetlands, which we wouldn't really have in Colorado, but it's stormwater diverted to permanent pools that incorporate wetland plants. And again, pollutants are removed by biological activity through the plants. Again, limitations, it should be at least 25 acres, so you need a fairly large area. And again, we wouldn't have any in Colorado because we are a semi-arid climate. So here is sort of a wetlands. The water is kind of running into these areas, and another little picture where all of your stormwater may feed into this wetlands because it retains a lot of its moisture naturally. Then you add moisture to that to just keep it as a wetland. So some size of stormwater ponds, these considerations, you got to consider the soil characteristics. Is it going to retain the water like clay? We have a lot of clay soil. Or is it just going to kind of let it soak through really quickly? How much water we need? What is the kind of contamination level? Where's the water coming from? Is it coming from large parking lots where it might be picking up a lot of pollutants? Is it coming from other areas that, like rooftops where you might not be getting as much pollutants from that? Also, the depth of the water table, considerations on how what the water table currently is, how you want to add to that, and then just general topography. What is the land sloping? How does that play into the water drainage? So this is something that I'm not going to ask you to actually record down. We're not going to do these size of stormwater ponds, but our general rule of thumb is you reserve 10% of the development area for the stormwater pond. So whatever area, again, you have, that's 10% of that is the size of the pond. So this is just sort of a formula to figure out what volume of stormwater, and again, this is just an estimate, how much volume in acre feet that you're going to end up having. And then again, the area of the pond is just the volume divided by the depth of the pond, and that's going to give you the area of the ground area that you need to incorporate. But we're not going to actually do those calculations. We're going to do something a little bit different. These are, if you know the area, then you can figure out the dimensions, if it's a rectangular shape, if it's a circular shape, an oblong type shape. So those things are usually done with land surveys to sort of figure out all the points that you're going to put in for that shape of that pond. And that is it for this presentation.